Hi, this is Jeff Spence, your Math 120 instructor for the Community College Denver, and this is the second half of the Week 4 discussion answers, so I'll just get right into it. Number 12 says, find the effective annual yield at an APR of 7.5% compounded monthly. So effective annual yield is what's interesting is when you have compoundings of interest, you actually get a higher yield than 7.5% of your money. So the effective annual yield is a shortcut formula to figure that out, and that's this formula here, effective annual yield. So Y stands for yield. So following this formula, we start with a double parenthesis. And give me 1 second here, I gotta refresh the calculator. Okay, so the double parenthesis, and then we start with 1 plus the rate. The rate was 7.5%, so 0.075. Divided by, I think it was compounded monthly, but let me double check. Yeah, monthly. So monthly, let me go back to the formula here. And then I got to do divided by 12 to the 12th power. That's the n right there. Minus 1, right parenthesis, and then times 100. We'll convert it to a percent. It says round to the nearest hundredth in this problem, so it's going to be 7.76%. So notice the rate is 7.5%, but your yield at the end of the year, thanks to the 12 compoundings of the year, gives you 7.76% yield. 7.76% yield. Find out how much Sally would have to invest now at 6.5% compounded quarterly in order to have $35,000 in 7 years. So this is a problem where we want to know what the investment now would be given what the future amount will be. So if you look at the formula, this is still compound interest. We're going to use formula number 5 here because we don't know what we want to invest right now, P, which stands for principal. We don't know that amount, but we know the future amount. So we're going to use that formula. So we're going to do the future amount, A, which is 35,000. So it's going to be P equals 35,000 divided by 1 plus 0.065, that's the rate, divided by compounded quarterly, so that's 4 times a year, to the 4 times 7, which is 28. So I'll just type in 28 there. Okay, so I'm going to plug that into the formula. So we're going to do 35,000 divided by parenthesis 1 plus 0.065 divided by 4 for quarterly compounding, and right parenthesis to the 28th. 4 times 7 is 28. Enter. So we would have to invest $22,287.04 right now in order to have that 35,000 in 7 years. So 22,287. How many cents again? 4 cents. That's my answer there. Okay. It says find the effective annual yield on an APR of 7.5% compounded daily. Okay, so notice this one was monthly, this one's daily. So following the formula there, oops, I'm just gonna go to, alright, so I gotta do double parenthesis, 1 plus the rate, which is 0.075 again, divided by, now it's compounded daily, so that's 365 days a year. Okay, right parenthesis to the 365 minus 1 times 100, and it's 7.79%. So notice the more compoundings, the higher the yield is. The answer, so let's say the yield is 7.79%, and that's because it compounds more. If it compounds monthly, it was 7.7%, 7.76%, which is higher than 7.5, and if it compounds daily, it's up to 7.79. Alright, it says find your balance. Make sure I've answered all these. Okay. Find your balance in interest after 6 years with an APR of 7.3% and monthly payments of $340. So notice this is monthly payments, okay? And it looks like we're going to be making monthly payments to save money. So if we look at our formula sheet, we're going to start going down into savings plans. This is not compound interest. All these principal amounts is just a one-time investment. Here under saving plans, the P is from regular payments. Okay, so the future amount A still stands for future amount, but P is how much we're investing every time on our regular payments. So if you look at this, it says our monthly payments are $340. So I'm going to try and remember this. 340, 6 years, APR of 7.3%. Okay, so I got to follow formula number 8 because I want to find the future amount, and I know the monthly payments. Monthly payments are 340, so that's what I start with. Sorry, monthly. I just want to show the formula sheet. So 340, plugging in the P there, right there, and then you see a bracket, but that's the same as a parenthesis. So you just do double parenthesis, and then 1 plus the rate, which I think was 0.063. Let me double check again, or 7.3. Okay. So 0.073 was monthly payments, so we're dividing by 12. Let me double check that too. Monthly payments, yeah. Okay, so I got this part to the 12 times, how many years was it? 6 years, I think. 12 times 6, okay, that's going to be 72. But if you're nervous, just do you can do the exponent in parentheses, okay? And then, so I'm there, minus 1, and then I'm ending the bracket there, okay? Divided by the rate, which is 0.073, divided by 12. We're doing monthly payments. So this money should grow to $30,602.80. $30,602.80. Double check that. That's what it'll grow to. So this will be the balance A. I'm labeling that future balance. Okay. Now the interest. Interest, when we make regularly payments, interest is always, interest we get got to take a couple steps to figure this out. So we're making regularly monthly payments of $340 every month for 6 years. So the total paid or invested, but I just say total paid, is the 340 times 12, because we're making them monthly payments, times 6 years. That should give us our total invested. So 340 times 12 times 6. We invested $24,480. And that was just our raw investment. But thanks to interest, it grew to $30,602. So interest, when we use formulas 8 and 9 and 10, it's always going to be your future amount minus your total paid. Okay, so that would be $30,602.80 minus the $24,480. And we get, I'm just going to do the subtraction backwards and then type in the positive number, 602.80, $6,122.80 interest. Okay, so it's labeled interest. Make sure you label both of those answers. Alright, and then the last one. It says you intend to create a college fund for your baby. If you can get an APR of 3.5% and want the fund to have a value of $173,079 after 16 years, how much should you deposit monthly? What interest did you earn? Well, looking at the formula sheet, now I know the future amount that I want to have. So I know this, so I can plug it in. And I want to find what I would regularly need to invest or pay into like a savings plan in order to get that money. So I'm going to use formula 9 here. Okay, so formula 9. I wanted to have how much? $173,079. Okay, let me just type that number in. $173,079. Okay, that's the first number in the formula right there. And I take that and times parenthesis, the rate divided by n. Well, the rate is 3.5%, and it's monthly. So 3.5% divided by 12. So 0.035 divided by 12. Okay, and how many years? 16 years. Okay, so let's look at the formula again. Alright, so I'm using formula 9. Down, so I got to divide, and I got to do a double parenthesis, bracket, and then parenthesis, so just double parenthesis. 1 plus the rate, which is 0.035, divided by 12. Okay, and I got to take this to the 12 times 16 now. I don't know that off the top of my head, so I'm just going to do 12 times 16 in parentheses. If you don't do it in parentheses, it's going to mess up. So make sure you do that. And then minus 1. And then the parenthesis there. That should do it. We're going to have to make payments of $673.76. So we're going to have to make payments of $673.76. Okay, and it says also what interest would you earn? Well, we got to figure out total paid. Total paid is the 673.76 times 12. We're making monthly payments for 16 years. So if we figure that out, 673.76 times 12 times 16, we would totally invest $129,361. How many cents there? 92 cents. Okay, so that's what we totally invested, and it grew to $173,000. So our interest, so I'm labeling it interest, would be the $173,079 that it grew to, minus the $129,361.92 that we invested over the span of 16 years. I'll just do the subtraction backwards again. Minus 173,079. Interest will be 43,717 and 8 cents. So 43,717 and 8 cents. Okay, so that's it. Make sure that you have your formula sheet ready when you're doing these problems and for the test, and we'll see you next time.